it says find all points on the graph where the tangent line is horizontal. This is a big gun for us. Tangent line is horizontal. If I think about a tangent line being horizontal, that's a horizontal line. That means that the slope of the tangent is what?
0.
The slope of the tangent is 0. And if the slope of the tangent is 0, that means that y prime equals 0. That's also f prime. What that says is take the derivative and set it equal to 0. Bless you. Now, when I look at the picture that I've drawn with a horizontal tangent, you'll notice that that horizontal tangent touches in one place. What would that one place be called in the graphical world?
Vertex.
A vertex, or a, begins with an M, maximum, right? So that says if I've got a horizontal tangent, I may be looking at a maximum or a minimum. So when I say take the derivative, set it equal to 0, that says find where you have horizontal tangents. That means I am looking for where there are possible maximum or minimum values on the graph. Well, something you can't really do in college algebra except for parabolas. If you had a cubic that had the W shape, you wouldn't know where they were. You know, you've got humps, you just don't know where they are. You can get approximations. You could use technology to find them as well. So if I take a look at this guy, it says find all points on the graph of the given function where the tangent line is horizontal. So if I look at him, I could either multiply this out, and I'm not sure I want to do that, or I could use product rule. Maybe that one might not be nicer, right? So I'm going to use product rule. So that f prime of x is the derivative of the first times the second plus the first times the derivative, I say I'm going to have fun with this, of the second. So this is the derivative of the first. What's the derivative of x plus 1? 1 times x squared minus 8x plus 7 plus x minus 1 times the derivative of x squared is 2x minus the derivative of 8x is 8, and then the derivative of 7 is 0. So now I need to simplify, and this becomes x squared minus 8x plus 7 plus, this gets multiplied together. Since there's a plus here, I don't have to worry about, because technically speaking, this is what I'm going to have. I multiply these two together, then I would apply this sign to it. The sign happens to be a plus, so life is nice. If that were a minus, it would change all of the signs. So x times x, 2x is 2x squared, and minus 2x minus 8x minus 10x plus 8. And combine like terms, x squared, this is 3x squared, and then minus 18x, and plus 15. So that's f prime of x. 2x squared plus 1x squared is 3x squared. Because there's a plus there, I can ignore the parentheses. Nice. And then I'm going to have an 18. Equals 0. I was worried there for a minute. But what do I notice this sucker has? A greatest common factor of 3. I can get those numbers down size-wise. Because what am I going to need to do? I'm going to need to factor it and solve or use the quadratic formula on it. If I can get the numbers down size-wise, it makes the problem manageable, and that's what we try to do. So it's a greatest common factor of 3, so x squared minus 6x plus 5 equals 0. Yippee! Look at that sucker. He factors. Whew. I would have never gotten that otherwise. So this is 3 times x minus 5 times x minus 1 equals 0. X is 5. X is 1. Now, I don't know whether they're maximums. I do not know whether they're minimums. I just know that, number one, this is going to be a polynomial. And I just know that these are humps and valleys, and or valleys. They could be humps. Well, no, they are humps or valleys. This is a continuous graph. You can say, how do I know it's continuous? It's a polynomial. Polynomials are continuous creatures. But I don't know whether it's a maximum or a minimum. I just know that's where these are the x values where the tangent and the horizontal. But it says find the points. If it means points, what are they looking at? The whole dang coordinate point, huh? So these are the points where it occurs. So these are the x values where y prime equals 0, or the slope of the tangent is 0. Now to find the y values, I've got to go back to the original function. I need to calculate f of 5. And f of 5 is going to be 5 minus 1 times 5 squared minus 8 times 5 plus 7, which is 4 times 25 minus 40 plus 7. This is a good place for your calculator, isn't it? Because it handles it much better than what I do. So it's 4 times 25 plus 7 is 32. 32 minus 40, what is minus 8? I hope. So that's the y value. So the coordinate point that I'm looking at is going to be x equal 5, y equals negative 32. Boy, that might be a minimum, might it not be? Maybe. Maybe not. Maybe it's the maximum. I don't know. Well, yeah, might be a minimum. Probably minimum. And then I need to calculate f of, what's the other number? Oh, I like 1. Oh, like it, lots. 1 minus 1 is? Woohoo! Do I care about what the other stuff is? No. Whew. I just know that sucker is 0. We'll take it. So this is going to be 1, 0. I have a pretty good idea that this is a maximum and this is a minimum. And then you might say, well, why is that? This is because if I look at the original function, we're going to do some college algebra here. I'm not going to multiply this out, but if I look at the highest power, which we call the power function, it's x times x squared, which is x cubed, right? Now, x cubed has a coefficient of what? 1. And it's a positive, right? Now, if I look at the end behavior of a cubic function, the end behavior of a cubic function is that if this is positive, it starts from the bottom and goes out through the top. It's opposite direction. If I've got 1, 0, it's sitting here. And if I've got 5, negative 32, it's down here. So that if I'm coming up from the bottom eventually it hits that, goes down, and then comes back up. So that's a maximum, that would be a minimum. That's using algebra. But in algebra, you can't find those particular points. You don't have a means of doing so. We do now. Cool, huh? Combination of algebra and calculus together. Yippee! No?